Hello, mathematicians! For our final test today, we are going to be working in our template packet. If you need to pause this video and get out your templates, go ahead and do this. I'm going to open it up, skip lesson 2, and we are jumping right into lesson number 3 today. So this is what your template should look like. This is what we are going to be working with for the last part of our lesson today. I'm going to work in pen just so you can see my answers clearly, but we know that you definitely need to make sure that you are using pencil. So let's take a moment and look at what we have here. We have a number line on top, and then we're going to be plotting some points. On this top number line, I'm going to go ahead and label all these larger lines, these bigger ticks, 1 to 5. I'm making them bold just so you can see it a little bit clearly. You don't necessarily need to do that, but I'm doing that just so you can see exactly where I am labeling. So the segment between each of these holes is divided into how many parts? 4, 5, 6, 7, 8, 9. Did you get 10? Let's check on the next one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal parts. On this number line on top, can you plot a number to represent 4 and 1/10? Let me repeat that. You are plotting a number to represent 4 and 1/10. And 1/10. Let's zoom in. Let's zoom in here and kind of get a closer look for letter A here. So I plotted 4 and 1/10 here, but I'm going to make this a little smaller because I have this whole number line and I didn't even use this whole chunk of it. So if I'm working on a problem that's asking me to plot, I think I just would rather zoom in to a shorter number line partitioned into tenths and work on that instead. So let's plot 4 and 1/10 on this number line. So it's between 4 and 5, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in there, and I'm plotting it 1/10 past the 4. So I'm representing 4.1 here. What is that as a mixed number? I really like the direction here. It's ones and then a fraction. So when I look at this number, I have 4 ones and I have 1/10. So I'm thinking to myself, what would that be as a fraction? 1/10. 1/10. Awesome. Okay, so now let's look at that in expanded form. We're going to do it in fraction or decimal form. I'm just going to do both. I really want to get that practice in. So check it out. I'm looking at my whole and I'm going to work backwards. So I'm starting with, well, I have 4 times 1/10. And that is going to be added to 1 times 1/10. That gets me an answer of 4 and 1/10. Okay. Now I can also represent that in fraction decimal form, decimal expanded form. I still have 4 wholes times 1/10, 4 wholes times 1, and then I have 1 times 1/10, and that gets me 4.1. Now I'm taking a look at this last point. How much more is needed to get to the next one? That's where this number line comes in handy. To the next one, to the next whole number, I would need to jump 1, 2, 3, 4, 5, 6, 7, 8, 9/10. So that would be like saying 9/10, or as a decimal, 0.9. So this is kind of reviewing some of the things that we've discussed before. We're going to repeat this process and we're going to work on some other numbers as well. So here's what I'm going to do for you. I'm going to fill in some of these in advance, and I'm going to offer you an opportunity here. You are welcome to jump ahead in this video after you get these numbers and do your work on your own. So what you'll do is you'll take these numbers that I am providing to you, and you can do this work independently. When you finish, you can jump ahead to the end of the video to see the finished product. If you'd like more practice, you can work through the next couple with me, and at any point, if you feel you're ready to try on your own, pause the video, work through the rest, then jump ahead to the end and see how your work compares to mine. For those of you that are interested in staying and would like some more work with me, I'm going to start on B. Otherwise, those of you that would like to try on your own, you're always welcome to do it on your own and then kind of move your video up or down to where you need to check your work, okay? So, I have 32.5. When I think of that on the number line, I need to think about, well, where does this fall between? It is not quite 33, but it is more than 32. Now I'm going to add lines in between to represent the 10 parts in between. 1, 2, 3, 4, 5, 6, 7, 8, 9. Notice how I add 9 lines, because every time I add a line, I'm creating 2 spots actually. So this is 32, 32 and 1/10, 32 and 2/10, 3, 4, 5, 6, 7, 8, 32 and 9/10, then 33. So I'm going to start by plotting that. 32 and 1, 2, 3, 4, 5/10 would be right here. And I'm thinking about, well, what does that look like as a mixed number? It's still 32 wholes, but what does that 5/10 look like as a decimal? 0.5. How can I translate that into a fraction? 5/10 is what is a fraction? You kind of almost say it when you're thinking about it, right? 5/10. So now here's that part that might be a little tricky for some of us still. How can we put this in expanded form? The big challenge with this one especially is that we have a number in the tens place as well. So think of it as each individual place value needs its own multiplication sentence. So I'm starting with the largest spot, and I have 3 tens. That's like doing 3 times 10. Then I need to look at my ones place and add that on. That's 2 ones. 2 times 1. Then I look at my final place, and I have to add on either the fraction or the decimal. I'm going to keep organized with my work and do the fraction first. 5/10. That's like doing 5 times 1/10. Wow, doesn't this remind you of some work that we did way back in the beginning of Module 5? So when I add all of that together, I get 32 and 5/10. Notice how I'm kind of checking along the way. 32 and 5/10. And I'm running out of room a little bit, so I'm going to put kind of tiny off to the side here. How much more do I need to add? Well, I'm halfway there. I need to add on 5/10 to get to the end. So now I'm going to repeat that same process, but I'm going to do that with the decimal expanded form. So I have 3 times 10 plus 2 times 1. Here's the big change, is really when you're in to your decimal place value. We have 5 times 0.1, and that gets us 32.5. We are halfway to the next whole. So we need to add 0.5, or you can also record as 0.5. We talked about that before. All right, let's move on to C, 40.7. Think about that number line. We are not quite to 41, but we are definitely greater than 40. It's almost like your number line always includes the number that is there and then the next one up. Then I add my 9 lines to create 10 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I need to go 0.7 in. I need to go 7/10 in. So that's 40 and 1/10, 40 and 2/10, 40 and 3/10, 4/10, 5/10, 6/10, 40 and 7/10. What does that look like as a fraction? If you really need to kind of help solidify your understanding here, you can always add decimals to your number line. Okay, so that would be 40 and 7/10. Here is that tricky part that it's not necessarily...
Erickson, if you could please come to the front office. Victor Erickson.
Sorry about that, guys. When we do this one, it's just a lot of steps. So kind of, once again, look at it as place value. I have 4 10s, no ones, 7/10. So I'm actually skipping my ones here. So I have 4 10s. That is 4 times 10. No ones. I don't need to document that. We talked a little bit before about 0 is just kind of 0. It's not there. We don't always need to acknowledge it in these circumstances, because when I add together, I'm going to include that 0. So now I just need to turn 7/10 into a multiplication expression. I'm going to start with my fraction. That would be like doing 7 times 1/10. That gets me 4 10s, no ones, and 7/10. Okay? And when I go to my next one, it is the same thing. 4 times 10 plus, oh, but in this scenario, we're using a decimal. That would be 7 times 1/10. And that gets me 40 and 7/10. How much more to get to the next one? To get to 41, I'd have to jump 1, 2, 3 tenths. And that would be what I would record on the side here. 3 tenths, which is the same as 0.3. So I'm especially noticing in all of my equations here, the only thing that's changing is my number of tens or my number of ones or even my number of tenths. Look at all these equations are times a 10, times a 1, times a tenth, right? We're so emphasizing place value here. So I hope that you're starting to recognize that pattern here. We're just taking a number and timesing it by its place value. So that goes way back to module 1, if you can believe it. Let's take a look at the last one, 90.9. I'm making my number line. I have 90, don't quite have 91, but it would take me 10 tenths to get there. 1, 2, 3, 4, and 90.9. I already know there's 10 tenths in here, and 9 is 1 less than 10. I'm almost going to work backwards to plot it on this number line. 90 and 0.9. 0.9 is the same as 9 tenths. 90 is just 90. I don't need to convert that at this point, but I do need to break it down when I'm looking at expanded form. So in the tens place, I have 9 tens. That is 9 times 10. Continuing with this pattern, we're timesing by 10, we're timesing by ones, we're timesing by tenths. Then I'm adding on 9 tenths, which is the same as 9 times 1/10. That gets me 9 tens, no ones, and 9 tenths. We already kind of talked about it, how that is 1/10 away from the whole. So when I think about this as a fraction, I always have 9 times 1/10, 9 times 10, right? Then I have 9 times 1/10, which can be represented as 1/10 or 0.1, and that gets me 90.9, which is 0.1, 1/10 away from the next whole, the next one. So I did that highlighting. I'm hoping that that stands out to you. The process, it only really adjusts based on the number you have in each place value. B is a really good example of showing you tens, ones, and tenths. So this is something that's going to be helpful, and I'm going to say, alert, alert. This is something that's going to pop up on your test. So make sure you hold on to this template. Make sure you hold on to this work because it's going to guide you towards the end of the module. Great work today.